Hello. Hello, everyone. Is I audible to all of you? Hello. Is I audible to all of you? Hello, everyone. Is I audible? Okay. And screen is visible to everyone? Screen is visible? Okay, good. So we can start here. So we start here. Good morning, everyone. I am Dr. Sunil Kumar Srivastava. And today in this our learning lesson, we are going to discuss our first lecture of the basic mathematics. And we try to understand the concept too much clearly. So if you have any queries regarding this one, you can raise your question in the last of the sessions. And between we have to listen the units very much clearly. So we start first here. That is the BCA first semester. Subject name is the basic mathematics. And today unit number 1 we are going to discuss. That is the most important part of the mathematics. That is the determinants. I am Dr. Sunil Kumar Srivastava, Professor of Mathematics. Before going to start the session, we have to know what is the guidelines we have to follow during the sessions. Already you are familiarized with these guidelines in every lesson and every lessons of your lectures. Maintain the display for a smooth conduction of the interactive live sessions. Type your name, program name in the chat box to mark your attendance. Raise your questions only after the completion of the sessions. Let's try. So we start here. We have to maintain the discipline in during the sessions. And finally, you have to avoid the posting of any irrelevant questions during the sessions. Interaction with the faculty should be constructive, no descriptive comments is stated here. For any issues or any queries, you can contact at the given support numbers or given email IDs. Before start the session, first of all, we have to come across the sessions. What is the learning objective of these sessions? What do they mean? What do you learn in this session here? If you, by the end of the session, you will be able to understand here what is the meaning of the matrix. First of all, we have to know what is the meaning of the matrix. Then after we define, if you know, we aware with the definition of the determinant. What is the definitions? Determinants. You have to apply the formula to derive and to find the value to how to solve a 2 by 2 order determinant, 3 by 3 order determinants, and so on. And finally, you have to also describe what is the meaning of the cofactors, what is the meaning of the minors. And of application point of view, we have to apply the properties of determinant to solve some different problem related to the determinants and so on. So this is the learning objective of the sessions. If we're going to start the session, we have to come across the points. What is the meaning of the matrix? First of all, we have to know what is the meaning of a matrix. What is the meaning of a matrix? So matrix is the most important used tool in the computer science, engineering, domain, physics, economics, statistics, and mathematics. That's a great application to find out the solutions of any difficult problems to coding in the theory or other application point of view. In the computer science, you have the application in finding the coding in the terms. You can apply the different types of situation and make this problem related to that one. In the engineering core branches, you can have the great application. You can find out the financial statistics, financial mathematics. Also, you can use it in the finding the solutions of the differential equation also. It is also used in the study of optimics, matrices employed to the account for the refractions or reflections. In addition, matrices are the most important part in the electrical circuit designing, quantum physics also, and the electrical domains. But this is the overview of the thing. This is the introduction part of the matrix. What is why we are going to read the matrix here and what is the meaning to related these topics. So first of all, we have to go through the definition. What do you mean by the definition here? How to define a matrix here? Matrix is nothing but it is a representation. It is a representation. It is an arrangement of the numbers in the row and the column. Suppose we have the 6 number. 6 have the factor 6 into 1. It can also in the two parts 2 into 3. It can be written in the part 3 into 2. It can also written into 1 into 6. So matrix is can be represented in 6 elements can be represented by the 4 ways. We can write is like this. It is the rectangular arrangement. Matrix, what is the matrix? Matrix is a rectangular arrangement of mn number. Mn means this is mn numbers in which elements are arranged in the rows and the column. Suppose we have the 6 elements and we arrange it in row wise. Suppose we in the first row we write the elements 1, 2, 3 here, and the second row we write the 4, 5, and 6 here. These are 6 elements. These are arranged in the format of the rectangular arrangements, row wise and column wise. So this way we have the read in this one. This is the row 1 first. We have to read the row 1. This is also read as the row 2 and so on. And we are going to vertically downwards, we get column wise. This is a column 1, this is the column 2 and column 2. So this arrangement is known as the matrix. The matrix is nothing but it is a rectangular arrangement of the numbers in row and the columns. If you are going to represent any number into the rectangular arrangements, rectangular arrangement be square also, it can be represented. That format is known as the matrix. Here we have taken the 6 elements. We can also represent the numbers in the 6 into 1 format. We write the elements all in 6 in 1 rows columns. So this is a different structure and different types of matrices will be arises and different types of different kinds of matrices will be defined one by one here. So once again, I'm going to define the definition of the matrices. What is the meaning? Matrix is nothing but it is the rectangular arrangement of the mn numbers in row and the columns. So we have written here some usual definition. We have to learn here what is the meaning. Right? Written here is system of numbers arranged in the form of rectangular array. Rectangular array in rows and the column is known as the matrix. How to represent the matrix? Any matrix can be represented by the capital letters. Capital letters of the alphabets A, B, C, R, X, Y, and Z. Its elements are represented by the lower cases, is the small letters, that is the A, that is the B, C, X, Y, Z. Any elements can be represented here. It is represented by the capital letters such as the A, B, C. Elements can be represented by the lower subscript that is known as the small letters of A, B, C. If suppose we have a matrix A, suppose we have write a matrix A that is denoted by the row and rectangular form like that. Suppose we write here, we take an example here. Suppose we write a 2, 4, 6, this is a 3, 2, 9, and 6, 1, 3. So this is a matrix. In this matrix, we are going to read, we see here, this is the row wise. This is the row 1, row 1. This is the row 2, row 2. And this is the row 3. So vertically, horizontal, we are going to read, that is the row wise understanding should be developed here. But we are going to column wise, that is the column wise, that is the column wise, like that. This is the column 1, this is our column 2, and this is the column 3. So this is the matrix. The first of all, we have to know what is the how many numbers are row here and how many numbers are column here. On the basis of that, you can define what is the order of the matrices here. The order is the most important part in the mathematics beside on the definition and the order of the matrix, where too much things should be clear and calculation purpose will be also cleared in that case. So first of all, we have to check order of the matrix. We have to calculate how many rows and how many columns here. So here we have find there are three rows. There are three rows, and we find here there are also three columns. So this matrix have the order 3 by 3. If a matrix have the m by n order, it means matrix have m rows and n columns. First number denote m by n denote the order. Means first number denote the rows and second number denote the column. So this is the order of the matrix. So we written here matrix of order n by n and written in the form of like that. How to represent its numbers here? How to represent its elements? How to denote it? This should be here. So first of all, we have to know what is the meaning like that. Suppose we are written here a number, and after that you can define some related terminology. Suppose we are going to discuss here. Now see here, elements of the matrix. This is written as A11, written as A1. This is the matrix A. We are going to write in this form. We write here A11, A12, and A13, and so on. Second, A21, A22, and so on. And that is the AN1, and so on. A11 means this is the position of the element. Where is the element is position located in the matrix form? A11 means first. A11 means it means its first row and first column. First row and first column. In this way, A12 means first row but second column. A13 means first row but third column. In the same sequence, what is the meaning of A21? Second row but of first column. Second row but of the first column. In this way, we can locate the position of the any element. We are going to talk about what is the A12, what is the A22, what is the A23. So you have to know the situation where the position of the element is situated in this context. So A11, A12, A13, A21, A2. This is the generalization of the representation of the elements. So A11, A12, I think should be clear to all of you. If you have any doubt, you can ask your question in the last of the sessions where I can discuss again with you. So first of all, you have to know the representation. In this sets, we have discussed the basic related to the matrices. First of all, I've discussed with you what is the definition of the matrix. Matrix is the rectangular arrangements of the numbers in row and the columns. Matrix is usually denoted by the capital letters X, Y, and Z. And small letters are denoted by the small letters. Its elements are denoted by the small letters. Its order is written by row into column. First of all, you have to count the row, and then you have to count the columns. Row into column give the order of the matrix. Not we have to take the multiplication, but we write in the terms of this one: 3 by 3, 1 by 2, 2 by 2. It means number of rows and number of columns should be the cleared here. How to represent the elements, how to locate the elements, how to elements should be allocated by symbols. That is the A11, A12. It means A11 means first row, first column. A21, second row, first column. A22, second row, second column. In this way, you can arrange and you can like that. Horizontal lines are known as the rows. Horizontal lines are known as the rows, and vertical lines are known as the columns. In this way, you can conclude all this related terminology of the matrix form here. Now, since this topic is related to the find out the values of determinants. So first of all, we have to go into definition related to the determinant form, not the detailed study of the matrices. We will study it in next part of our relations. Here we are going to discuss what is the meaning of the determinants. First of all, we have to know a determinant is a scalar values of a square matrix. So what is the meaning of a square matrix? A matrix in which number of rows and number of columns are equal. Number of rows and number of columns are equal. A matrix in which number of rows and number of columns are equal. 1 minute, hold beta. Please wait 1 minute. So determinant is the scalar quantity in which number of rows and number of columns are equal here. That is the number of rows 1, 2, 3, 4. And that is the suppose here 2 rows and 2 columns is here. Any matrices, the number of rows and number of columns are equal. So that is known as the square matrices. That is known as the square matrices. For every square matrices of order n, for every square matrix of order, we can associate a number, real or the complex form. The determinant of the square matrix denoted by is Aij, order of the elements is denoted by Aij. So suppose we have a matrix A here, 1, 2, 3, 4. Its determinant is denoted by the horizontal lines like the determinant of A and can be written in the form of that like in the two horizontal lines, that is the 1, 1, 2, 3, 4. So this is the form of the any determinant form of the any square matrix. Suppose we have a matrix A that is given by the form that is the 2, 3, 4, 6. So therefore, its determinant it will be written in the form that is the 2, 3, 4, 6. 2, 3, 4, 6. 2, 3, 4, 6. 2, 3, 4, 6. Now, so this is the meaning of the determinant of a matrix. Here we have written the detail. Determinant of a square matrix of order 2 by 2. This is the square or determinant of the matrix of order 2 by 2. Let A be a matrix. Let A be a matrix. So we have written here, this is the matrix A, whose elements are given in the form of, that is the here, that is the A11, that is the first row and first column, A12 first row and second column, A21 second row and the first column, and A22 the second row and the second column. Okay. Then determinant is represented by, if for any square matrix, how to write determinant in the two verticals line, that is the A determinant of A, read as the determinant of the given matrix, and write all the elements of the matrix in the horizontal, vertical lines, like that. A11, A12, A22, and A21 and A22 in this way. Suppose we have a matrix A whose elements are given by 3, 4, 6, 7. This is a matrix of order 2 by 2. Here 2 rows and 2 rows. Determinants of can be find of those matrix which elements are in a square matrix, in the number of rows and the number of columns. This can be written in the form here, that is the determinant of A is equal to determinant form, that is the 3, that is the 4, that is the 6, and that is the 7. 3, 4, and 6, 7. 3, 4, 6, 7. This is the determinant form of this matrix. 3, 4, 6, 7. How to find out the value of this determinant? This is the most important. What I have to do? You have to multiply this element to this element. Suppose we have to multiply here 3 into 7, then put the sign minus and multiply with 4 into 6. 4 into 6. That value is 21 minus 24, which is equal to minus 3. Will be answer for that one. So determinant value we always find here 2 by 2 matrix, multiply A11 with A22, A11 with A22 minus sign A21 to A1. We have to multiply with this one. So in this way, you can find out the values of this one. A11, A22 minus of A21, A1. A11, A22 minus A21, A1 to here. So finally, this is the process to find out the value of any determinant of order 2 by 2. You may ask, you could know the process how to find out the determinant of order 2 by 2. Once again, I can repeat with you. Now, suppose we have a determinatrix of order 3 by 3. We have a determinatrix A, that is elements are given here, first row, first column, second row, and third column, third row. This matrix is of order 3 by 3. This matrix have the 3 rows and 3 columns, that is the square matrix. And its elements are given by A11, A12, A13, A21, A22, A23, A31, A32, A33. That is the element, 3 by 3 elements is here. Now, so determinant values given by determinant of A is equal to, in the, we have to write in vertical lines, all the elements A11, A12, A13, A21, A22, A23, A31, A32, A33. We have to know the patterns of every elements. First elements have this plus sign, plus, minus plus minus, plus minus plus. Every element have the sign, that is first element plus, minus, plus. This is the element with minus, plus, minus, and plus, minus, plus. This is the sign of any element. You can open this determinant 3 by 3 here in row wise or any column wise. You can open this one. You can open it by any row wise or any column wise, this determinants. So we are going to learn here how to open. This is the most important, how to going to open. You have to learn very clearly here. Suppose you have determined A values here given. You have to listen very carefully. Otherwise, you are not able to understand what is going to be happen here. A11, A12, A13. That is the A21, A22, and A23, and A31, A32, and A33. This is the matter, determinants. And we are going to open this, find out the value of this one. How to open? We are going to open this determinant by first row. This is the first row. This is our first row. We are going to open it row 1. This is the most important. I'm always using. You can also use this one. How to use this one? First of all, we have to take this one. Row 1 have the element A11. We have taken here A11. Now, we have to see after taking the sign is also always here plus. We have to take it here plus here. And after then you have to think what is here. We have to delete all we have to ignore that row in which this element lie. A11 lie in the first row and the first column. The remaining element, that A22, A23, A32 and A3, A31, A32 and A32. This is the elements we have to put here. A22, A23, A32 and A33. Next step, we have to come across the point A12. A12, you have the sign -1. So here we have the sign -1, A12. And after that, we have put in here A12. Okay. And same, just we have to think in which row and in which column is it have. It is in second column, but it also in the first column. So remaining element is there A21, that is here, therefore A21, A23, that is the A23, A31, that is here A31, and here A32, that is the A33. So this is the second step. Third step is that is the A13 here. We have right here A13 sign is also here plus. We have taken the plus. And same we have to take in which this column is lie this element. This lie in the third column, but in the first. So remaining is the A21, A22, A31, and A32. And after that, we have to just open this 2 by 2 determinant, just we have discussed with you earlier, and you can find out the value of any 3 by 3 order determinant, any 3 by 3 or 3 order determinants. You can find out the value of any 3 by 3 order determinants. Now, moving forward, some information related to this. How to open, how to write, and what is the meaning of this one. So first of all, we have to know determinant of A is not absolute value of any this one. We have also write the matrix. We have a matrix A. Its determinant is denoted by determinant of A. Read it, determinant of A. It's not its meaning of absolute value. Absolute means its value is not always positive. It can be negative. It can be also be negative 0 or anything value itself we have, but it's the scalar values. So it's not absolute value. This is the difference here. Determinant gives the numerical value, but matrix does not give the numerical values. Determinant always have the numerical, it always also the values of 0, 2, 1, 5 like that, but not have the matrix have not the numerical values. A determinant always have the equal number of rows and columns. Determinants have the always equal number of columns. Number of rows and number of columns should be the equal. For easier calculations of the determinant, we expand the determinant along the row or the column wise, which contain the maximum number of zeros. Okay. And suppose we have a matrix A of order n, the determinant of A is equal to x. Its absolute value, Ka matrix determinant of n denoted by the k raised to power of n determinant of that values. So this formula can be also be used by multiplying to any scalar quantity of that determinant values. You can find out the value of that thing. Now, we have to know the definition of any minors of a matrix. What is the meaning of minors? We have to know across the point. That is the most important part of this one. Minors of any elements, any matrix denoted by the ith row and jth column as with the element is lies. The minors of any element is denoted by the elements M, I, C. It is the numerical value. Suppose we are going to find out the minors of this element A11. So we have written minors of the element A11 is denoted by capital letters of M11. How to calculate? We have to read this thing in which row and which column this element is light. Just leave that. Remaining elements will give the remaining elements determinant form will give the minors of that elements. So remaining elements is that A22, A23, A32 and the A33, and its determinant form will give the minus of that. And its open value is always calculated. We have to multiply this element to this one and minus to this one to this one. Similarly, we are going to find out the minus of element A12. Suppose we are going to find out the minus of this one element A12. What is the meaning of this? First of all, we have to leave in which column it lie, in which row is lie. We have to just leave remaining elements A21, A23, A31 and A33 is the minus of that element. Suppose you're going to find out the minus of this element A33. So just we have to take in which column live, in which row lives, remaining element A11, A12, A21, A22 will be the minus of that elements. Minus of an element of a determinant is determined by obtaining the deleting the ith row and jth column in which the kth element is lies. In which kth element is lies. Minus of an element is of order denoted by the order n minus 1. An expanding form of minus given by A11, M11, A12, M12, and A13, M13 is the expanding form of the determinant of any order of the matrix A. So we move forward here. Cofactors. What is the meaning of cofactors? What is the meaning of cofactors? Suppose we have elements. What is the meaning of minors in the cofactors? That is they are simply related to each other, these elements of this one. The minors of any elements that is denoted by MIC. Minors of any element denoted by any element. Suppose we are going to find the values of any elements of this one. So we can they give the definition of the any element cofactor of this one. So cofactor of any element AIJ is denoted by the formula -1 raised to power I plus j MIC. We will discuss in detail with an example here. Suppose we have a matrix here. We have a matrix A is here that is given by the elements A11, A12, A13. That is the A21, A22, A23. And here is A31, A32, and A3. This is the supposed matrix. And we are going to find out the minors of the element A11. Minors of element, cofactors of element A11. So cofactors of element A11 denoted by the capital letter of A11. Its formula is given by -1 raised to power of in which rows and in which column it lie. It lie in first and first column. So 1 plus 1 and minus of this one M11. We have to find out the value of this one. M11 means in which row and which column is deleted. Remaining elements in the determinant form will be given the minors. So A22, 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 A23, and A32 and A33. This is the remaining elements. A22, A33 minus A23, A32 is here. So this is the element -1 is to power of 1 plus 1. Similarly, we can find out the values of the cofactors of all the elements. We have to calculate the cofactors of all the elements. That is the A11, A12. Suppose going to find out the calculate the value of cofactors of element A22, A22. That is denoted by A22. How to write? First of all, we have to write -1 raised to power in which row, in which column it lie. It would lie in the second row and the second column. So therefore 2 plus 2 Now then we have to take the minus of this one. Suppose it lie in the second row and the second column. So remaining A11. This remains A11. Here remains A13. Here remains A31 and A33. This is the values of this one. So values will be here A11, A11, A33 minus A13 into A3. This is the minus value, cofactors value of the element A22. This is the cofactor value of A22 here. Similarly, we can find out the cofactors of any elements. What I have to do? Suppose you are going to find out the cofactors of the element A21. What I have to do here? We have to just see minus 1 raised to power in which row, in which column is light. It's like the second or first column, so 2 plus 1. And leave that row and that column in which it lie. The remaining row and column will give the value of that minus. So in this way, we can calculate all the remaining terminology related to finding the calculation of the so some we have the some other things related we have to discuss here. The value of the determinant will not be changed if the row and the columns are interchanged. If you're going to change the row and column, the value of determinant should not be changed here. Suppose the determinant value of A and determinant value of the transpose does not have the property that is known as the reflection properties. Suppose we have a determinant value 5412, 54 that is given by determinant of A is equal to that is the 5412 and its values calculate have to multiply 5 into 2 that is multiply 5 into 2 minus 1 into 4. 1 into 4. So 10 minus 4 is equal to 6. But we have to change the row. We have to change the value row and column. Then what is the changes here? We have to change the value 5142 and also value have the 6 here. But this reflection properties also hold here. If are going to change the row and column, its value is not be changed here. Its value is not be changed here. Now we have the switching property. What is the meaning of switching property? That is the properties are very useful to calculation of the value of the determinant. That is most important. What is the meaning? The value of determinant multiplied by minus 1 if the row and two columns are interchanged. If you're going to change the value, suppose we have a determinant here, that is the 1, 2, 3, 4, 1, 2, 4, and 2, 4, 6. If we write this determinant in like that, we have to change the second column to first place and first to second here. That's multiplied by the sum letters. We are going to change it row wise, that is when we change the column wise. Here we have written the ABC, IJK, and PJQ. We have changed the first row to the third row here. So it's multiplied by the sign minus 1. If are going to interchange any rows or any column, the sign of the determinant would be changed also. We have the plus, we have to get the sign minus 1. These are the values. Non-singular and singular matrices. That is the most important part. Suppose we have a matrix A. Suppose your matrix A 2, 4, 2, 4. Suppose a matrix. And its determinant values finding that determinant of A is found by 2, 4, 2, 4. And its value is going to be equal to 2 into 4 minus 2 into 4. That is equal to 0. Suppose a matrix have the determinant value is equal to 0. It's said to be the singular matrix. It's said to be the singular matrix. And the determinant value is not equal to 0. Determinant value is not equal to 0. It is said to be the non-singular matrix. If the value of the determinant corresponding to a square matrix is 0, then matrix is said to be the singular matrix. Otherwise, it is said to be the non-singular matrix. The determinant value will define the kinds of the matrices, like the singular matrices or non-singular matrices. Determinant value is 0, matrix is the singular. If determinant value is not 0, matrix is non-singular. Non-singular. Some theorems related to this one. A and B are the non-singular matrices of the same order. If suppose we have two matrices A and B, and that are the non-singular matrix. Non-singular matrix means their determinant value is not equal to 0. Then AB, product of the AB matrices and product of the BA matrices are also non-singular matrices of the same order. In the same sequence, the determinant of the product is equal to the product of their respective determinant. And determinant of the product of two matrices A and B is equal to the determinant of A into determinant of B, which are the same square matrices of the same order. So that is the concept here. This is the some important property. How to calculation of the determinant should be becomes very much easy here. So we have to know the some properties. First of all, is listen, see here. The elements in the two rows or two columns are identical. If a given the determinants and its two rows are equal or two columns are equal, then value of determinant is going to be 0. Here we see here its first row, that is the 1, 2, 3, and second row is also 1, 2, 3. Here two rows are equal, R1 and R2 are identical. So value of this determinant is here 0. Value of this determinant is here 0. In the same sequence, if the two columns are equal, then same sequence value of determinant is going to also equal to 0. That is the properties number 1. If the elements of the two rows or two columns are identical, then value of the determinant is going to be equal to 0. Value of determinant are going to be equal to 0. Value of determinant is going to be equal to 0. The elements of the two rows and two columns are proportional to each other. Here, first row is that, first column is that 1, 1, 2. First column is that 1, 1, 2. First column is that 1, 1. First column is that 1, 2, 1, 1, 2. And second third column is that 3, 3, 6. It means third column, that is the C1, 3, C2. C3 have this third column is C3, and its value is multiple of third times multiple of first column. If you multiply in the first, 3 become 1 becomes 3, 1 becomes 3, 2 becomes 6. This is the proportional to each other. The first column is proportional to third columns. In that case also, value of the determinant is going to be equal to 0 here. Value of the determinant is going to be equal to 0 here. Okay. All the elements in any rows or columns are equal to 0. The value of the determinant is also equal to 0. Suppose we have a determinant here, its third row's value is 0. So its value is going to be 0. So any rows or any columns, all the elements are 0. Then value of that determinant is equal to 0. Then value of that determinant is equal to 0. Then value of this determinant is equal to 0. Now, if all the elements of determinants are consecutive on orders, means valid for the third and higher order applicability. We are going to discuss the find out the value of the higher order, that is the third order, fourth order, fifth order determinant values. Then this property is applicable here. That is the first row is there 1, 2, 3. Second row is the 4, 5, 6, and that is the 3, 7, 8, 9. In that case, if all the elements of the determinant are consecutive order, suppose 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are in the consecutive order. So the value of determinant is equal to 0. If the first row of each element is start with the second element of the previous row, then such element of the determinant are consecutive orders. It means 1, 2, 3, 2, 3, 4, 3, 4, 5. It means we start with 2, 3, 4, and that is the 5. So value of such type of determinant is also equal to be 0 here. Value of such type also determinant is going to be equal to 0 here. So these are the some topics we have discussed here with you in detail to find the value of the determinant in this way. Now we had discussed here all the things we have to discuss with you. What is the meaning, how to calculate these relations to find out the values of these determinants. Some questions we have to discuss. We have to take an example to describe the details like here, how to calculate the values. Suppose we have a determinant value that is the 1, 2, 3. Its value is the given 3, 4, 1, and that is the 2, 1, 3. 2, 1, 3. Okay. And we are going to find out the value of this determinant. What I have to do? We have to open this determinant by the row 1. This row 1 is first element is 1 here. So we write here 1. Remaining that what I have to do? We have to just look here in which row, in which column it lie. It lie in here, we see here first column, and it lie in our second column. First row and first column. So we have to ignore it. And remaining elements are here 4, 1, 1, 3. We write here 4, 1, 1, 3 in this way. Okay. Next we have to move here second element, that is here 2. We have write here 2, but the sign is sign till plus minus plus. The second sign is here minus 2. We write here minus square 2. And the same sequence we see here in which row and which column it lie. It lie in the first row, but it lie in the second column is here. So here 3, 1, 2, 3. 3, 1, 2, 3. In the same way, we have here for the third element, that is the plus 3. Okay. And which row it lie? It lie in the first row, but in the third column. But lie in the first row, but in the third column. So remaining elements are 3, 4. That is the 3, 4. And 2, 1. That is the 2, 1. That is the 2, 1. So what is the value? This one, we have to multiply 4 into 3. 4 into 3 minus 1 into here minus 2. Multiply 3 into 3 minus 2 into 1. Plus 3. 3 into 1 minus 2 into 4. So after simplification, what is the value? 1. 4 into 3, what happened? 12 minus 1. That is the 1 into 12 minus 1. 1 into 12 minus 1 common to 11. That is the 11. Okay. Then minus 2. Minus 2. 3 into 3, 9. 9 minus 2. 7. 7 into 2 multiplied by 2. That is the 14. And the same sequence is here. 3 into 1, 3 minus 2 into 4, 8. That value is the minus 5. Minus 5 into 3 means minus 15. That is the minus 15. And its value is calculated here after solving. That is the minus of 18 here. The value of this determinant is going to be equal to minus of 18. So these are the some problems for the practice here. You can use this one to find out the value of the determinant, how to calculate and how to find out the value of this one. You can also we have the written examples. We have written the some clue here also given. You have to follow the instructions. We have to follow the rules, and then after you can calculate all the values related to find out how to calculate the 3 by 3 order determinants, third by third order determinants. How to find out the third order determinants? Now we have the some one more problem is here. We have to discuss with you what is the values of this determinant to find out the solutions related to like that. You can find out the value of some questions. Suppose we have a problem here. Find the value of x for which the determinant is given by x plus a into b, that is here a, and the value of x plus b is equal to 0. This is the value. So first of all, this is the determinant form here. 2 by 2 determinant. We have to multiply determinant by 1 and find out the value of this one. So we have to do, we have to multiply this one to this one. Means x plus a. We have to open this one, x plus a into x plus b. And then after multiply with this one with minus and minus of ab is equal to 0. Just we have to make the simplification of this one. This means x square. We have to multiply this on x into xa, that is the plus of xa plus of ax or plus of ab minus of ab is equal to 0. This becomes x square plus of x is common, a plus b is equal to 0. We take the common x, we find x plus a plus b is equal to 0. It means x is equal to 0 or x is equal to minus of a plus b. This is the answer for that. In this way, we can find out the solutions for remaining of these things. We can calculate the values. You can find out the values of this one is given in the term of this way. So, value of x is equal to 0 and value of x is equal to minus of a plus b here. Value of x is equal to a minus b is here. In the same sequence, we can also arise some problems related to this one. We are going to find out the some values is here. How to calculate this one? We have taken some example also here. We can, there's so many problems related here to solve the find out the solution either like that. We are going to find out the value of any type of problems that is given by the determinant of the given matrix. Suppose we have matrix A, the value is given by here 8 minus x, that is the 10, and this is the 5. Then what is the value of determinant? The determinant of denoted by the determinant of A. It can be also in the written form, determinant A. We have find this words also. It is meaning also is here, that is the value give to determinant of the given value of A here. So what you have to do? You have to multiply this one 8 into 5, 8 into 5 minus of sign 10 into minus of 6. So we have to give 40 minus is equal to 50. That is equal to 100. In this way, you can calculate the value of any determinant of the type. We are going to find out the discussion for discussion point of view. So this is the things I suppose we are going to find out the value of this one. Also, we have discussed with you some problems related to the minors and the cofactors. Suppose we have a matrix A whose elements are given by 4, 2 and the 3, 5. And we are going to find out the minors. The minors of A is how to calculate. It's take first of all in which row it lie, in which column it lie. The remaining element is the 3. The minors of 4 is equal to 3. In the same sequence, minors of 2 is equal to 3. Minus of 3 is equal to 5. 2, and minus of 5 is equal to 4. So this way, we can calculate the minors of any values or as per our choice and as per our base here. So we have discussed here in details with the terms of the learning outcomes, outcomes of the sessions. We have discussed here in detail with you the definition of the matrices. We have discussed with you in details. Definition of the determinant, how to matrices and a determinant of definitions should be calculated by each other. How to calculate the determinant of order 2 by 2 and 3 by 3. What is the meaning of the minors? What is the meaning of the cofactors? What is the properties of the determinants? And how these properties are very much useful to in the calculation of the 3 by 3 determinants and higher order and second order also. How determinants on the basis of the determinants, singular and non-singular matrices are defined. If any matrix has determinant value is equal to 0, their matrix is known as singular matrices. And any matrices which determinant value is not equal to 0 is known as the non-singular matrices. So theorem based on the some numerical questions also given and discussed with you, and some problems I have discussed with you in details to describe our relation more very much clearly to all of you. Now from your side, any questions you ask to ask for your learning, any doubts from your our sides, you may raise your questions, you can ask, you can raise your hand for discussion point of view. Any questions you want to discuss? Any question from your sides? Anyone? Any question from your side? Anyone want to ask? Please raise your hand from your sides. And someone asked how to get this PDF for PDF PPT. The PDF is downloaded by your mailbox. You can directly get there. There you can contact your given support number. PDF is always with them, and you may ask. They will provide with you. If you want to get the lectures, and if I find any question, you can also post me. Given support number also given the support given academic support number is also given with you. Already in this first slide, I have given the academic support numbers here, and number is also given here, and the email ID is also given here. You can also post your queries here, and you can also raise your queries here, and I will give the answer with you. Any PDF like that, you may ask here. Okay. Okay, thank you very much. I understand you have enjoyed the sessions.